Hi Math 1 students, Mrs. Robinson here to work Practice Benchmark Chapter 4 with you, so you can come here and get help on problems you need help with. Let's start with the first one. Solve the system by graphing. So you've got these two equations and we are in slope-intercept form already, which is our graphing form. Just to remind you, y equals to m times x plus b. The number next to the x is your slope, and the b, or the constant, is your y-intercept. Okay, that's our graphing form. It makes it super quick to graph. So equation 1, I can see in equation 1, let's label this equation 1 and equation 2. In equation 1, my slope, or I use m for slope, is 4. And my y-intercept, or my b, is negative 11. Okay, and that does not look like an 11. Let's try that again. All right, in equation 2, my slope is negative 2, and my y-intercept is 7. Now remember, slope, I always like to write slope as rise over run. Or if it's negative, I like to fall first and then run. Okay, so here I have 4. Now how do I rise over run? Well, if I have a constant like 4, I'm going to put it over, or a whole number I should say, I'm going to put it over 1. So I rise 4 and I run 1. Always start with your y-intercept at negative 11. So I'm going to come here, remember this is my y, my vertical is my y, and my horizontal is my x. I'm going to come on my y-axis and go down 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's off the graph. So the graph only goes down what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The graph only goes to 8. So you have to be very careful when you're solving this by graphing. I'm going to rise 4, run 1 from my y-intercept. So I'm going to go up 1, 2, 3, 4 over 1. Rise 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. All right, that should be enough for me to make my line. And from here, I'm going to draw a line through my points. And I did not draw a very good line. Let me try that again. Let's start here and see if I can hit them. There we go. All right. And let's see, that line goes on forever, so it does have arrows. Let's see where it hits this line. So this line, my y-intercept here is at 7. So 1, 2, 3, 4, 5, 6, 7, all the way up here. And here my slope is negative. Since it's negative, I'm going to write negative 2 over 1. Negative means instead of rising and running, I'm going to fall first. So fall 2, run 1. Fall 2, run 1. Fall 2, run 1. Look, that's where I'm going to intersect. Fall 2, run 1. All right, that's enough to see where my two lines intersect. So I'm going to go ahead and draw it. And then I'm going to put my arrows on. And that point where they intersect is right here. And it's the point over 1, 2, 3, up 1. So 3, 1 will be their point of intersection, and that's the system. That's where these two intersect. So my solution would be 3, 1. Make sure you tell me the solution and show me your graph. One thing you can always do to check your graph, since you're graphing by hand, you have to be really accurate to get that point of intersection. Check your graph at Desmos.com. I'm going to pull it up real quick. Okay, so if I went ahead and graphed those two graphs from number 1, I would type in y equals 4x minus 11. There's my first graph. And then my second graph would be y equals to negative 2x plus 7. There's my second graph. And I can come over here. I can zoom in. I can zoom out. I can see that this point right here at 3, 1 is where those two intersect, and I've done it correctly. So use Desmos.com. It's a great grapher to check, to work with your graphs. Another thing I want to show you real quick before we go on to the second one is this. Make sure with your slopes, you can tell here, this slope is positive and this slope is negative. And you should always know this. I check it with the buggy. Here's my little car. When my little buggy goes up the hill, I'm positive. When I go downhill from left to right with my little buggy, I'm a negative slope. When I'm driving on a flat surface with my little buggy, there's no slope here, 0 slope. When I go straight up a wall, my buggy can't drive up this wall unless I'm SpongeBob. This is undefined slope. Okay, 0 slope and undefined slope are perpendicular. Positive and negative are perpendicular. So check it and make sure you have a positive slope. So the red line, positive, you're going up here. Yep, I do have positive slope. I did it. Check this one. Do you have negative slope? Well, it is going downhill, so I do have negative slope. So at least I know my slopes are looking good when I graph this. So check that. Okay, this one says, one of the measures, I just drew myself a little triangle because I like pictures. One of the measures of the angles of a triangle is 25 degrees. Okay, and the sum of the measures of the other two angles is 155. I don't know what they are, but I know x plus y is going to be 155. That makes sense because if I go 155 plus 25, I should get 180 because that's how you add up the angles of a triangle. They need to add up to be 180. Okay, so if you know the sum of the measures of the other two angles is 155 and you know their difference is 5, what are the measures of the unknown angles? So let x be one unknown angle and y be the other. You're given two equations here. You're given that the sum of these two guys is going to be 155 and then you're given the difference. The difference between them, subtract them, is 5. Okay, so now you've got a systems of equations and you know they should add up to be 180. Let's see if we can figure out x and y. So you could solve this by substitution or you could solve this by elimination. I'm going to go ahead and go with elimination here. Okay, if I do elimination, I'm just going to add these two. I'm not even going to subtract them because if I add these two equations together, the x's are going to be 2x's. X plus x is 2x. The y's will fall out if I add them. That's why I chose to add, because the y's will fall out. Y minus y is 0. Bring down the equal sign, and then 155 plus 5 is 160. Now finish this by solving. Solve for x by dividing both sides by 2, and then you're going to get x equals 80. Now I've solved for x, I can come back in to plug into either original equation to get y. I choose to plug into equation 2. It looks, actually either equation will work. Let's plug into equation 1. So I'm going to go 80 plus y equals 155. And then I'm going to subtract 80 from both sides. And I'm going to get y is going to be 155 minus 80. Bring down the 5, 15 minus 8 is 7, so y is 75, and I've solved it. X is 80, y is 75. So I'm going to have 80 degrees for x and 75 degrees for y. And there is my solution. All right, on to number 3. All right, we've got to solve this system by graphing. Remember, when you solve by graphing, you have to be super accurate with your graphs. We want to be in slope-intercept form. That gives us our graphs. Y equals to m times x plus our y-intercept. So equation 1 and equation 2. In equation 1, my slope is the number next to the x, or 2. My y-intercept is here. My b, I'm going to use b for y-intercept, is -4. Okay, slope I like to write as rise over run. So since there's no denominator, I make it be 1. In equation 2, our slope is the number next to x. It's already in slope-intercept form, thank goodness. I don't have to solve for y, so half of it's done for me. So I have 3 over 5 for my slope here, and my y-intercept is 3. Okay, remember this is your x and this is your y. We need to say if it's 1, infinitely many, or no solutions, okay? So let's go ahead and graph this. So equation 1, my y-intercept is -4, 1, 2, 3, 4, down in the negative direction, and I put it right there on the y-axis, y-intercept. Okay, my slope is 2, or 2 over 1. That means rise over run. So from my y-intercept, I rise 2, I run 1. Rise 2, run 1, rise 2, rise 2. And there is my line, and I'm going to try to be very accurate. It helps if you use a straight edge and a ruler if you're drawing this by hand. I'm going to try to be as accurate as possible. Those have arrows on it. It does go on forever. Okay, and then let's go to the second equation. I'm going to graph this one in blue so we can see it. So here equation 2 is in blue. My y-intercept is 3. So I'm going to go positive 1, 2, 3 on the y-axis. And my slope is up 3 over 5. So I'm going to go up 1, 2, 3 over 1, 2, 3, 4, 5. There's my intersection point right there. So I'm not going to graph again. I could go up 3 over 5 again, but I already see where it's going to lie. It's going to lie right there, my intersection point. So do your arrows. Goes on forever. There's my intersection point, so figure out what that point is. It's over 1, 2, 3, 4, 5 on the x, and up 1, 2, 3, 4, 5, 6 on the y. So over 5 on the x, up 6 on the y, and that would be your solution. So does it have one, infinitely many, or no solutions? It has one solution. The solution is 5, 6, and that is the graph. Okay, so make sure you tell me one solution, make sure you graph it, and you tell me what the solution is. Infinitely many solutions would look like a line and then another line on top of itself. Okay, that's infinitely many solutions. Basically, they're going to end up being the same line. No solution would be parallel lines. Okay, you can tell if you have no solution or parallel lines, meaning they never touch. They would have the same exact slope, like they would both have a slope of 2, but different y-intercepts. And that's why they have no solution. If I had parallel lines like this, they would have different y-intercepts, but they would have the same slope up and over, up and over, up and over, and up and over, up and over. So look at your graph and see if they have the same slope but different y-intercepts. Then you'll know you'll have no solution. Okay, let's go on to number 4. Solve each system by using substitution. So they specifically say substitution. I want to see your work here. This is a great one to do by substitution because y is already solved for. So in equation 1, y is already solved for. In equation 2, I'm going to take y and plug it in, this stuff in for y in equation 2. So I'm going to go 3 times, instead of y, I write negative 2x plus 5. And then that will equal negative x minus 5. Now I'm going to solve for x, and then I can come back up here and figure out y. So distributive property first. 3 times negative 2x is negative 6x. 3 times 5 will be 15, and that equals negative x minus 5. Do all the math here. Get your x's together. So I like positive x's, so I'm going to move these x's over to here. If you do it the other way, that's fine. You'll just have negative x's. So I'll plus 6x to both sides. That leaves me with 15 equals negative x plus 6x is 5x's minus 5. Get your x's alone. Get rid of that. Plus 5 to both sides. Okay. And then I get 20 equals 5x. Get your x alone now by 5 is multiplied by x, divide by 5. And you're going to get, if I take it up here, 20 divided by 5 is 4. 4 is going to equal to x. Now I've solved for x. I'm not finished. I'm going to come back and plug into either original. It's easier to plug in here to get y. So in equation 1, I'm going to get y equals 2. X is 4, so I'm going to go negative 2 times 4 plus 5. Well, negative 2 times 4 would be negative 8 plus 5. Sorry, that's ugly. Plus 5. Negative 8 plus 5 would be negative 3. So y is negative 3, x is 4. So go ahead and write that as an ordered pair, 4, comma, negative 3. Or write x equals negative 4 and write negative 3 equals y. Write those out, okay? So y, that's a y. Sorry for the, it's really hard to write with this. So 4, negative 3, x, y. Don't flip them around. Be very careful. All right, so that's number 4. Let's go on to number 5. Here, solving this by substitution. This is already solved for y, so I'm going to go ahead and plug this in to here for y. Yes, I do have some fractions, and that is ugly, but I can work with it. Plug it in here for y. So I'm going to go x plus 2 times, plug this in for y, negative x over 4, or negative, I can write this as negative 1/4 x if you choose, plus 4, that's what I have to write in there for y, and then that's going to equal 6. So this is equation 1, this is equation 2. I'm rewriting equation 2 where I plug this in for y. So x plus 2 times this blob equals 6. Now I only have x's, so I can go ahead and simplify. 2 times this, and then 2 times this. So 2 times this, let's write it up here. 2 times negative 1/4. 2 and 4 would cancel. That becomes 2, and that becomes 1. So I'm left with 1 times negative 1, which is negative 1, divided by 2. So that makes this 1/2. So this becomes negative 1/2 x, and then 2 times 4, it becomes plus 8. I still have this x here, so I have x plus negative 1/2 x plus 8 equals 6. Let's go ahead and simplify this. 1x minus 1/2 an x is going to be 1/2 an x, 1/2 x, plus 8 equals 6. Peel off the 8. I got to get x by itself. Peel off the 8, so subtract 8 to both sides. You get 1/2 x equals 6 minus 8 is negative 2. Now I want to get x by itself. It's multiplied by 1/2, so, or divided by 2, you can think of it. To get rid of 1/2, I multiply by 2 on both sides. That gets rid of the 1/2, and I've got x equals to negative 2 times 2, which is negative 4. Now I've solved for x. Come back up to the originals and figure out y. So you can plug in negative 4 right there, and you're going to get, this is equation 1 over here, you're going to get y equals, I'm plugging negative 4 into negative x. Please be careful there. X is negative 4, and then I have a negative here, so I'm going to plug it in. So I have negative, and then x is negative 4. This is a double negative here. Divided by 4, so I plugged it in there, plus 4. So negative negative 4 turns this to positive 4. Positive 4 divided by 4 is 1, so I have 1 plus 4 here. That's what y is going to equal. And 1 plus 4 is just 5. So I've got x is negative 4, y is 5, and my ordered pair would look like this. Negative 4, comma, 5. And there's your solution. Okay, you gotta love these. The difference of two numbers is 43. The sum of two numbers is 13. What are the numbers? Well, you gotta define a number. Let x equal the first number, and let y equal the second number. Okay, and then you can go, the difference between the two numbers, subtract them, is 43. Okay, and sorry, that should be a 3, is 43. So that's the difference between two numbers. The sum of the numbers is 13. That means I'm adding them. The sum, x plus y, is 13. What are the numbers? Well, you got a system of equations here. My suggestion would be to solve this by elimination. Just add the two together. The y's will fall out. So add them together. X and x is 2x. Negative y plus y is 0. Add these together. 3 and 3 is 6, 4 and 1 is 5. So 2x equals 56. Divide both sides by 2. Okay. X is going to equal to, let's see, dividing this out, you're going to get 28. Then come back, you've solved for x, plug into either original, it doesn't matter. You can plug 28 in for x here. You're going to get 28 minus y equals 43. Solve for y, subtract the 28 from both sides. Okay, if I do 43 minus 28, you can do the borrowing or you can use a calculator. 13 minus 8 is going to give you 5, and then 3 minus 2 will give you 1. So you're going to get negative y equals 15, and I can't have a negative y, so I divide both sides by negative 1 or multiply, it doesn't matter. You're going to y equals to negative 15. So y is negative 15, x is 28. So your first number is 28. Your second number is negative 15. And there's your solution. All right, there are 785 students in the senior class. That's a big senior class. If there are 77 more females in the class than males, how many males and how many females are in the senior class? So that's a big class, and there's 77 more females. So when you do these, always start by defining a variable. So we can do M and F if you want. M for males, F for females, or just do the X's and Y's. Let X equal the number of males, and then let Y equal number of females. And you can also say females is going to be X minus 77, right? Or did I say that wrong? Females is going to be X plus 77. Okay, because there's 77 more females than males. So I did say that wrong. All right, so let's set up a system of equations. If we know there are 785 students in the senior class, we're going to go the males plus the females. So the number of males plus the number of females is going to be 785. Okay, and then we also know this system of equations. The number of males is going to be the number of females minus 77. Or if that doesn't work out for your brain, you can say the number of females is going to equal the number of males plus 77, okay? Because there are 77 more females than males. So if you take the number of males and you add 77, you get the number of females. So there's your system of equations. Go ahead and plug this in for y in the first equation, and you're going to get x plus, and then plug this in, x plus 77 equals 785. Add these together, 2x plus 77 equals 785. Peel off the 77 first. You're going to get 2x equals, if I do, let's see, 77, do the subtraction here, you're going to get 708. Then divide both sides by 2. And you're going to get x equals 354. Remember, defining the variables is important. X is the number of males. So to get the number of females, which is here, I'm going to go 354, and that's a 4, plus 77. Okay, so what's that going to be? The number of females is going to be 431. So there's the number of females, there's the number of males. So males, and this equals females. Make sure you circle it nicely so I can find it. All right, on to the next. Okay, solve this guy by substitution. Tell whether the system has one solution, infinitely many, or no. Remember, one solution is where they cross. Infinitely many means the same line. No solution is parallel. Okay. All right, looking at this, if I solve this by substitution, I'm going to take this and plug it in for y into equation 2. So if this is equation 1 and this is equation 2, plug this into y here because it's already solved. So new equation 2 is going to look like this, negative 3x, and where there's a y, I plug in 3x minus 6, plus 3x minus 6 equals 6. Now solve for x. 3x plus x, well, interesting. The x's fall out, and I get negative 6 equals 6. When is this true? Does negative 6 ever equal 6? No. This has no solution, okay? Which means these lines are going to be parallel. When you come up with a contradiction like that, you have no solution. If I came up with 6 equals 6, this would be infinitely many solutions, but that's not what I came up with. That's no solution. That's not true. Negative 6 does not equal 6. Now, if I were to rewrite these equations, this first one, just so you can see this is in slope-intercept form already. There's my slope, there's my y-intercept. Put equation 2 in slope-intercept form. So here's equation 2. I'm going to write it down here. This is negative 3x plus y equals to 6. If I want to solve for y, I'm going to add 3x to both sides. Okay, and I'm going to end up with y equals, if I write this in slope-intercept form, this will be 3x plus 6. So here's equation 1. Here's equation 2 in slope-intercept form. Y equals to 3x plus 6. Remember, we talked about this. If the lines are parallel, they have the same slope and different y-intercepts, which they do. This one's -6, this one's +6. So looking at these two equations in slope-intercept form, if I were to graph them, you can see they would be parallel. One would have a that's a really bumpy line. One would have a y-intercept up here at 6, and one would have one down here at -6, if that were actually a pretty graph. Okay. All right, so this has no solution. When you get a contradiction, no solution. Okay, solve these by using elimination. Elimination, let's go ahead and add these together because the y's are going to fall out. Nice, the y's fall out. 2x's and 3x's is 5x's. That equals to -5 plus -10 would be -15. Divide both sides by 5. And you're going to get x equals to -15 divided by 5 will give you -3. Now come up here, you figured out the first part. Plug it into either equation to get the second part, or y. So I'll plug into here in equation 1, and I'll get 2 times -3 plus y. It's so hard to write with this pen. Okay, so, and then I got 2 times -3 is -6 plus y equals -5. Add 6 to both sides to solve for y. And you're going to get y equals to -5 plus 6, which is 1. I've solved both of those. If you want to write it as an ordered pair, you're going to write -3, +1. That's a +1. So let me erase this. You're going to get -3, 1. And I need my drawing tool back. Come on, draw. There we go. -3, 1. All right, let's go on to number 10. Number 10, I want to solve this using elimination. Now the x's and y's aren't naturally going to fall out nicely here. So I want to get one of these to fall out. I can see the x's aren't multiples of each other, but the y's, all I would have to do is multiply this by a -2 or by a +2 and then subtract, either way. So if I want to add, I'm going to multiply both sides of equation 2 by a -2. You have to multiply this side and this side by -2. To make it balanced. So equation 1 stands. We leave that guy alone. 4x plus 2y equals 2. Equation 2, I'm going to rewrite. Okay. Equation 2, that says equation 2 even though it's ugly. Sorry. Equation 2, I'm going to multiply -2 times 3x, which gives me -6x. -2 times y, which gives me -2y. Now you see when I add those, will fall out. And then -2 times 4, which gives me -8. Now I've multiplied both sides of the equation by -2. I've kept my balance. Now I can go ahead and use elimination, the little trick that I do. I'm going to add these down. Now because these are equal to each other and I'm adding to this side and to this side, I'm once again keeping a balance as I create a new equation. So add these together. 4x minus 6x is going to be -2x. 2y minus 2y, that eliminates. If it didn't, I didn't do it right. And then I go 2 minus 8, which gives me -6. Now go ahead and solve for x. Divide both sides by -2. I'm going to get x equals -2 divided by -6 will be +3. I've got my x. Come back to either of the originals. Plug in x. Let's just plug into equation 1. Okay, so up here I'm going to do that. 4 times 3 plus 2y equals 2. Solving for y, 4 times 3 is 12, plus 2y equals 2. Subtract 12 from both sides to eliminate that. And then I've got 2y equals -10. Excuse me. 2 minus 12 is -10. Then divide both sides by 2. And I'm running out of room. I'm going to get y equals -10 divided by 2 is -5. So I've got my two solutions. Make sure you circle them so I can see them. X is 3, y is -5. And this will be a little bit harder type of elimination where you do have to multiply both sides by something before you get it working. All right, on to number 11. All right, number 11, there were 155 people at the basketball game. Tickets for the game are $2.50 for students and $4 for adults. If the total money received for admissions was $492.50, how many students and how many adults? So always make your variables based on the question, how many students and adults? So if you want to use X and Y, let X equal number of students. That says students. Let Y equal number of adults. Okay, so if we want to set up some equations, our two equations could look like this. The number of students plus the number of adults will be 155 people. That was our first thing. Now let's look at the cost. The tickets for a game are $2.50 for students and $4 for adults. So we're going to go $2.50 or 2.50 times the number of students plus $4 times the number of adults. That's going to be the total cost, $492.50. Okay, so now I've got two equations and two variables. My choice for solving this would probably be substitution. I would solve for X or Y in equation 1 and plug it into equation 2. So let's take equation 1. And if I go ahead and subtract Y from both sides, like this, that would give me X equals to, the Y's eliminate, and I would have 155 minus Y. So there's new equation 1, all right? Now let's take this and plug it into equation 2 for X. So 250, and instead of X in equation 2, I'm going to plug in 155 minus Y. And then that's going to be plus 4Y. And then set that equal to 492.50. Now I need to solve for Y. So I'm going to multiply this through by 250. So if I multiply this through by 250, or 2.5, 2.5 times 155 is going to give me 387.5, and just do that on a calculator. And 250 times Y will be 2.5Y plus 4Y equals 492.5. Sorry, I can't write very small with this little tool that I have here. And then combine the Y's. So if I have 4 Y's and I subtract 2.5 Y's, I'm going to have 1.5 Y's left. And that's going to be 387.5. And then I combine these two plus, that's a 1. 1.5, oh, it's so ugly. Let me try that again. 1.5 Y's equals 492.5. Now I want Y by itself, so I subtract 387.5 from both sides. And that's going to give me 1.5Y equals, subtract that out, 492.5 minus 387.5 is going to give me 105. Now solve for Y, divide both sides by 1.5. And I'm going to get Y equals, if I do 105, divide that by 1.5 on a calculator, that's going to give me 70. So I've solved for one part. Y, the number of adults, 70 adults. Now I need X, the number of students. I can plug it into either of the original equations, but this is equation 1, just remodified to solve for X. So plug it in here. So I'm going to go X equals 155 minus my Y, which is 70. 155 minus 70 is 85. So X is 85. And remember, you needed the number of students plus the number of adults to be 155. So if the number of adults was 70, you subtract that from 155 to get the number of students, which is 85. So 85 will be the number of students, and 70 will be the number of adults. And there are your solutions. Okay, let's go on to number 12. Number 12, solve the system using elimination and tell whether the system has one, infinite, or no solutions. So let's go over that. Now, elimination, I want to see your work on this. If I solve this by elimination, I need the variables to line up. And I need these to be the same or these to be the same in order to fall out. Now, neither of them are the same. So the easiest thing would be a multiple. I know 2 is a multiple of 6, but 3 and 4 are not multiples of each other. So let's multiply this equation by 3. And then that would make this be -6, and these would fall out by adding. So if I multiply both sides of the second equation by 3, I can get this to fall out. So let's write equation 1 here, and this will be equation 2. Equation 1, I'm going to rewrite the same. I'm not going to change equation 1. Equation 2, if I multiply both sides of the equation by 3, I've kept my balance. So I'm going to get -6x, and then 3 times 4y would be plus 12y. And then 3 times 18, what is 18 times 3 is 54. Okay. So now new equation 2 looks like this. It's just a multiply of 3, multiply both sides. Now I can combine equations, and the reason I can do that is because these two are equal to each other. So if I add this to this side and this to this side, I'm adding the same thing to both sides of the equation. Combine these fall out. That's what I wanted. If these don't fall out, then I didn't do it right. These fall out, and I've got 12y minus 3y. Gives me 9y. And then I'm going to go 54 and subtract off 18, and that gives me 36. Then divide both sides by 9. And then after I do that, I get to plug it back in. Well, let's do this first. Y is going to be 36 divided by 9 is 4. Okay, so I've solved for y. Now I'm going to come back into either of my originals and get x. So at this point, it doesn't matter which original. Let's plug it back into original 1 right here. And let's go 6x minus 3 times 4 for y equals -18. 6x minus 3 times 4 is 12 equals -18. Add 12 to both sides. No, it's a 12, sorry. Add 12 to both sides. Gosh, that 2 is hard to get down there. I get 6x equals -18 plus 12. It's going to give me -6. Then divide by 6 on both sides. X is going to equal -1. So I've got my x and my y, if you want to write it as an ordered pair, -1, 4. Now, how do I know if I have one, infinite, or no solutions? Well, I do have one solution. I found it. I would have infinite solutions if I solved this and I came up with something like 9 equals 9. Always true. I would have no solution if I solved this and I came up with 9 equals 5, which is never true. So I don't have either of these. I actually have a solution, and that solution is -1, 4. On to the next one, number 13, the perimeter of a rectangle. Let's pull it up. The perimeter of a rectangle is 66 centimeters and its width is half its length. What are the length and the widths of the rectangle? If you're one that likes to draw a picture, go ahead and draw a little picture of a rectangle if it helps you think about it. If you know you have width here and length, and you know the perimeter all the way around is 66. Okay, so all the way around is 66. When you have a perimeter, you have 2 widths and 2 lengths. You add them up to get 66. We also know the width is half the length, so write that out. You know the width equals 1/2 the length. What are the length and the width of the rectangle? Well, we can figure out the rectangle's perimeter because 2 widths and 2 lengths is 66. So we're going to go 2 widths plus 2 lengths is 66, the perimeter. So look, you've got 2 equations and 2 variables. Equation 1, width is half the length. Equation 2, 2 widths and 2 lengths is 66. I would solve this by substitution because width is half the length. So just plug this in for width in the second equation. So 2 times, instead of W, I'm going to write 1/2 L plus 2 L's equals 66. Simplify this. 2 times 1/2, those cancel, and I'm just left with L. 1 L plus 2 L's are 3 L's. So I'm going to write this over here as 3 L's equals 66. Then divide both sides by 3. So 3 goes into 66, and it's going to leave me with 22. So there's my length. Now to find my width, I know my width is half my length. So just plug 22 into the original equation. Width equals 1/2 times 22. So half of 22 is going to be 11. Okay. And do we have that in centimeters? Yeah, it's in centimeters. Centimeters, centimeters. So I have my width, I have my length, and I've solved it. If you want to make sure this works, you can plug it in and just make sure 11 plus 11, and then 22 plus 22 does equal 66. And then you know I've done it correctly. So check it. All right, number 14. There are 2 different jobs in jobs Jordan is considering. Her first job will pay her $4,200 per month plus an annual bonus of $4,500. That's pretty good. The second job pays her $3,100 per month plus $600 per month towards her rent and an annual bonus of $500. Which job should she take? So let P equal her total pay. All right, if P is her total pay, and we'll let M equal the number of months. All right, you could do X or Y here. You could do X for the number of months and Y be the total pay if you're stuck on your X's and Y's. Either way, let's figure out which job she should take and at what point should she take this job, okay? Let's go ahead and look at this. If we look at the first job, so job number first, the first job, it's going to pay her $4,200 every month. So 4,200 times the number of months she works there, all right? Plus an annual bonus of $4,500. Okay, plus $4,500. If this was a year pay, so that would be a total year's pay if we plug 12 in there, and then you get that $4,500 bonus. Annual means once a year, okay? Now the second job would pay her $3,100 per month, okay, plus $600 per month, plus another $600 every month towards her rent, and then plus her bonus, annual bonus of $500. Okay, that will be that pay. So she just gets that once a year. So once you go past 12 months, this annual bonus is going to change. All right, but let's try to figure out how it adds up. Now, the $3,100 and the $600, I can add this together. This is going to be $3,700 per month plus $500, and that will be that pay. So this will be the second job, and this is the second job rewritten. Okay, so here's first job, here's second job. I want to know which job should she take. Is there going to be a point where the first job pay equals the second job? This one pays more per month, and it gives $4,500 in bonus. This one pays less per month, and it gives less of a bonus. How will this one ever catch up to this one? I don't see how it's gonna. This pays more per month and has a bigger annual bonus, less per month and a smaller annual bonus. The first one is the job she should take. Now, if I want to check it out mathematically, I could set these two pays equal to each other and see at what month the one catches up to the other. But it's never going to happen. Just try it. $4,200 per month plus her annual bonus of $4,500. When does that equal? At what month does that equal the second job, which is $3,700 per month plus an annual bonus of $500? Now, if she had that flipped around, and this one was $4,200 and that was $3,700, you might have something to look at. But one pays better per month and he has an annual bonus. It's silly. Solve this. Subtract 3,700 M's from both sides. Okay. If I go, let's go 4,200 minus 3,700 is going to be 500 per month, and then plus 4,500 equals 500, because I'm just rewriting my equation. Solve for m, subtract 4,500 from both sides. Okay. When I do that, I get 500 times m equals 500 minus 4,500 is going to be negative 4,000. Divide both sides by 500. Okay, and then your months is going to be, if you do 4,000 and you divide that by 500, it's going to be negative 8. So at negative 8 months, these two equal each other. So never. You're not going to go back 8 months to get a job. The first job is always going to pay more than the second job. Okay, the second job is never going to catch up. It pays less and it has less of a bonus. You can see that before you even do the math on it. Okay, first job. Easy peasy. Let's go on to solving the next set of systems. So we got 15 and 16. Let's solve this system. It doesn't say how I have to solve it. I just have to solve it. So if I solve this system, let's see. If I want to solve this by substitution, I would have to solve for y. If I want to solve it by elimination, I need to line up the variables. Let's try elimination. Let's take equation 1 and equation 2. Let's rewrite equation 1 by getting all the x's and y's on this side like this one is. So if I add, I'm going to take equation 1 up here. Negative 2y equals negative 4x minus 2. If I add 4x to both sides, okay, and I rewrite this, this will look like this. 4x minus 2y equals negative 2. So here's new equation 1. Now the x's and y's can line up with these x's and y's. So I'm going to rewrite equation 1 under here. And I'm going to write it as 4x minus 2y's equals negative 2. Okay, so now the x's and y's line up, and then the constant's on this side. So I basically added 4x to this side. Okay, if I do it to both sides. Now I can use elimination, because look, if I add these together, the y's will fall out. Yes, let's do that. Let's add together. 3x's plus 4x's. I can add together because remember, these two are equal to each other. So I'm adding the same amount on this side as I'm adding to this side. 3x's plus 4x's are 7x's. 2y's minus 2y's fall out. The equal sign brings down. And then 9 minus 2 is 7. Divide both sides by 7, and you're going to get x equals to 1. You've solved for x. Plug it into either original to get your y. Yeah, it doesn't matter. Plug it in here. So let's go to equation 1. I'll just write it over here so you can see it. I'm going to go negative 2y equals negative 4 times, remember my x is 1, minus 2. So negative 4 times 1 is just negative 4. That's what that is. And negative 4 minus 2 would be negative 6. So negative 6 equals to negative 2y. Divide both sides by negative 2 to get the y by itself. Y is going to be negative 6 divided by negative, and negative gives a positive. 6 divided by 2 is 3. Y is 3. X is 1. So you will have the ordered pair 1, 3, and that is your solution. On to number 16. Solving this one, I'm going to go ahead and do this one by elimination also. Here's my equation 1. Here's my equation 2. Now if I add, my x's don't fall out, but I'm going to subtract. So I'm going to go minus everything. Minus this, minus this, minus this. This becomes a plus. Double minus becomes a plus. So the x's fall out. Negative 2y's, let's fall those out. Negative 2y's minus 3y's is going to be negative 5y's. Bring down the equals. That negative became a plus when I subtracted because it's a double negative. So 9 plus 1 is 10. Be careful with your double negatives, guys. Solve for y, divide both sides by negative 5. And then you're going to get y equals 10 divided by negative 5 is negative 2. Ding, ding. Okay, I've solved for y. Come back up either equation to solve for x. Let's do equation 1. Let's plug in equation 1. I'm going to go x minus 2, I plug this guy in here, times negative 2, equals 9. Once again, a double negative, so x negative times a negative is a positive 4 equals 9. Subtract 4 from both sides, and you're going to get x equals to 9 minus 4 is 5. So y is negative 2, x is 5. If you want to write it as an ordered pair, remember x goes first, y goes second. And there's your ordered pair, and you're done. On to the next. Okay, graph each linear inequality. You're going to graph your inequalities just like equations. I'm going to go over my favorite steps just real quick. Step 1, graph into slope-intercept form. So rewrite your equation if it's not. This one is not, this one is not. Solve for y. Okay, solve for y. Be careful, if you multiply or divide by a negative, you have to flip. Okay, but solve for y. Once you solve for y and you're in slope-intercept form, this is equal sign, you will have an inequality sign. Go ahead and graph that. Now, the second step is if you have a less than or equal to, or a greater than, if you have a less than or greater than, you have a dotted line. If you have a less than or equal to or greater than or equal to, you have a solid line. That means you include the line because it has the equal to. If you don't, you have a dotted line. And the third step is, once you're in this, if y is greater than or equal to, you shade up. If y is less than or equal to, you shade down. Okay, so there's your steps. Make sure, first solve for y, flip the sign if you multiply or divide by a negative. If not, just leave it alone. Okay. Look at, if you have a greater than or less than, you have a dotted. If you have a less than or equal to or greater than or equal to, solid. If y is greater than, you shade up. If y is less than, you shade down. And that's how we do those. And let's do the first one, 17. Y is less than 5. This is in slope-intercept form. I don't have y equals mx plus b. I don't have something times x. That's because my slope is 0. I just have y equals to b here, or y is less than b. So what that means is I come to my y-intercept of negative 5. 1, 2, 3, 4, 5. And it doesn't matter what x is, y will always be 5. My slope is 0, which means I have a flat line. Okay. Now I look at this, second step, greater than or equal to, or less than or equal to, or just less than greater than. Y is less than. It's not equal to, so I don't include the line. I make it dotted. Okay, this is a dotted. And then since y is less than, I shade below the line. Okay, let's go to this one. I need to be in slope-intercept form, so I have to solve for y. First, I subtract x from both sides, and then I'm going to get negative y is greater than negative x plus 8. I like to write my x first. That's how I like to write it. So negative x, and then you have a positive 8. I still haven't solved for y because there's a negative in front of the y. So I'm going to divide both sides by negative 1, and red flags should go off. When I divide by a negative, I flip the sign. Okay. So bringing this down, I'm going to have y. I had to flip that sign is less than. And then negative 1 has to distribute to both terms. A negative divided by a negative gives me a positive 1, or just an x. Negative 1 into the positive 8 gives me negative 8. So here is now my equation, or my inequality. Okay, and I'm going to erase this so I have some room. So I've rewritten it in slope-intercept form. Remember, that was step 1. Step 2, solid or dotted. Well, this is less than or equal to, so I'm going to go solid line. And then y is less than this, so I shade down. Okay, y is less than, I'm going to shade down. So let's go ahead and do all that. I can see that my y-intercept is negative 8. And my slope isn't written, it's just 1. So there's my slope, which I can write as 1 over 1. So I start at negative 8. 1, 2, 3, 4, 5, 6, 7, all the way down here. There's my y-intercept. My slope is 1, or rise over run, 1 over 1. Rise 1, run 1. Do another dot. Rise, run. Rise, run, rise, run, rise, run, rise, run. You can do as many as you want. Remember, it's a solid line because it includes the line. It's got that equal to sign. So I do that solid line. And I go ahead and connect the dots right there. And then remember, lines have arrows on them, okay? And then I do shade below the line. So here's my shading. It looks like this. And then you're done. Let's do this one. I want to get it in slope-intercept form, and then solid or dotted, and then shade up or down. So first, get it in slope-intercept form by solving for y. Get rid of the negative or 5x by subtracting 5x from both sides. Then I'll have 5y is greater than, I'm going to put this first because I like my x first, negative 5x, and then it's a minus 10. To get y by itself, I divide by 5. I did not divide by a negative, so I don't flip the sign. Keep it the same. And I'm going to write this down here. Y will be greater than, and then 5 divides into both terms with the distributive property. 5 into negative 5 gives me negative 1x. 5 into negative 10 gives me negative 2. There is, I've solved it. It's now in slope-intercept form, and I'm going to erase this so I can see my graph. And let's erase this because it's kind of in my way. Okay, so let's go ahead and look at that. And we look at that, there it is. Here is my y-intercept. Here is my slope, which I can put over 1. Now, this is greater than, not greater than or equal to, so I do have a dotted. That's my second step. And my third step, do I shade up or down? Well, y is greater than this line, so I shade up. Okay, slope-intercept form, dotted, shade up. Let's do it. My y-intercept is at negative 2, 1, 2 on the y. Remember, x is always horizontal, y is always vertical. So negative 2 on the y for the y-intercept. The slope is negative 1, and I always put it over 1 if there's no denominator. I rise over run, but if it's negative, I fall first. Fall over run, and run is run to the right unless you change it. If the denominator is negative, then you can run to the left. So y-intercept negative 2, I fall first and then run 1. Fall first, run 1. Fall, run. So if it's negative, you fall instead of rise. Okay. So you do all the falling and the running, falling and the running, falling and the running. Okay. Remember, this is also equal to 1 over negative 1. Negative 1 divided by 1 is negative 1. 1 divided by negative 1 is negative 1. So if you want to look at it like this would be rise because it's positive, but this is negative, so you would run left. You could rise 1, run left 1. Rise 1, run left 1. And you can see it. It keeps you in that same line. So this is equivalent to this. All right? Let's be aware of that. Okay. So fall, run to the right. Positive means run to the right. All right, so there's my line. It's dotted, so I'm not going to connect it. I'm going to do one of these dills. Dot my line, okay? And I can keep going up this way. There's my dotted line. And I put my arrows, and then I shade up above the line. So there's my shading. I'll try to make it as pretty as possible. Okay, and this line's going to continue dotted like this, so it look like this. And there you have it. All right, let's determine whether this ordered pair is a solution to this linear inequality. Really, this is the easiest problem. All you have to do is plug this in to here and see if this is true. This is your ordered pair. It's an x comma y. So your x is 5, so I plug in 5 for x. 2 times 5. Your y is negative 1, so I plug in negative 1 for y. So I'm going to go minus 4 times negative 1. Is that greater than 5? So I plugged in 5 for x, negative 1 for y, and I'm going to see if this is true. Well, 5 times 2 is 10. Negative 4 times negative 1 is a negative times a negative is a positive 4. 10 plus 4 is 14. So 14, is that greater than 5? Yes. So this is a solution, which means it falls somewhere in, a solution. Like for example, if this were my line, it would fall in the gray solution area. So yeah, it's true. This is not the line for that, by the way, but yes, this is true. Because this is true, this is a solution. So all you do is plug it in and see if it's true. If it's false, then it's not a solution. Write the linear inequality that represents this graph. Okay, guys. Remember, inequalities are y. An equation would be y equals mx plus b. Inequality would be greater than or less than. So you need a y-intercept. You need a slope. And then you need this to be greater than or less than, or greater than or equal to, or less than or equal to. And you can tell that by solid or dotted. So let's start here. We have a solid line. So I'm going to be greater than or equal to or less than or equal to. Because remember, solid line is a greater than or equal to or less than or equal to. Dotted line is just greater than or less than. Solid line, so it's going to be one of these. Now, if I shade down, I have a less than. If I shade up, I have a greater than. Well, I shaded down, so I know this is my guy. So I already know I have y is less than or equal to, just from glancing at this graph. Solid line means less than or equal to. Down means less than or equal to. Okay? So now I need a slope and a y-intercept. Well, find your y-intercept, look at your graph. Here's 0. It looks like it intercepts the y-axis right here. Look at how it's numbered. It goes 2, 4, so that means this is 1 right here. Okay, so my y-intercept is at 1. So there I have that. Now I just need my slope. Count your slope. You have to hit right on a square. So it goes down 1. It doesn't go over 1. It doesn't hit anything. It goes down 1 over 1, 2. So my slope falls 1 and runs 1, 2. Falls means negative. It falls 1, it runs 2. So my slope will be negative 1/2. Slope is negative 1/2 x, and then my y-intercept was 1. There, I've done it. So guys, it's pretty easy to look at the graph. If it's solid, you have a less than or equal to, greater than or equal to. If it shades down, you have the less than or equal to. So I already knew that. Then I looked at the graph and found my y-intercept. I plugged it in for my y-intercept. I looked at the graph, I found my slope by going down 1 over 2. So my slope is negative 1 over 2. Put that in for slope, and there I have it. Not too hard. All right, let's go to number 22. All right, 22. Each child at the birthday party was given $5 to spend at the arcade on games and rides. Each game costs 25 cents. Each ride costs 50 cents. Write an inequality for the number of games and rides each child can enjoy for $5. What's the max number of games or rides each child can enjoy? So if we want to do X and Y, you can do X and Y, or you can do games and rides. So if you want to do G for games, G equals number of games. Okay, and then R equals number of rides. Always define your variable based on the question. What is the number of games or rides each child can enjoy? What is the max number of games or rides? Okay, so we want to know number of games, number of rides. All right, let's go back to our information and figure this out. We know he was given $5. So that's all they can spend is $5. Okay. So we're going to write an inequality for the number of games and rides they can enjoy for $5. They can't spend more than $5 because that's all they have. Okay. So we know that all of this stuff that I do, $5 is the most they can spend. So everything has to be less than $5. $5 is the max. It can be greater than or equal to. All of this has to be less than $5. I know it's 25 cents, so 0.25 times each game, plus it's 0.50 or 50 cents times each ride. So the number of, it's a quarter per game plus 50 cents per ride. Add that together, that's got to be less than or equal than $5. $5 is going to be greater than that amount. So looking at this, there's my equation, there's my inequality. The second part asks me, what is the max number of games and rides each child can enjoy? We'll write an inequality. We did that part. We found the inequality. So we want to know the max number of games or rides. Well, if I have $5 and I only want to play games, if I have $5 and I only want to play games, I'm going to go $5 equals 0.25 times games. They're a quarter a game, so divide by 25 cents. If I have $5 and I divide it by 25 cents, how many games can I play? I can play 20 games, okay? So your games have to be less than or equal to 20. Now, if I only did rides, I have $5 and it's 50 cents a ride. You guys can probably do that in your head. If it's 50 cents a ride and you have $5 and you're at the carnival, how many rides could you do? Divide by 0.50 or divide by 50 cents. You could divide by 0.5, it's the same thing. If I do 5 divided by 50 cents, I'm going to get 10 rides. So the rides have to be less than or equal to 10. So what's the max number of games they could do? 20. What's the max number of rides? 10. Okay, and there's an inequality for both. That was B if you only do games or if you only do rides, not if you do both. Okay, there's different things that you could do if you did a certain number of games and a certain number of rides. All right, let's do 23. Solve the system of inequalities. So if we're going to go to system of inequalities, it's just like systems of equations. We're going to graph it. But it's really hard to solve systems of equations. We're going to solve these by graphing only. Okay, so let's look at this. X plus y is greater than or equal to 3, and 2x plus 2y is less than or equal to 2. To solve these by graphing, remember, we first put them in slope-intercept form. So let's go equation 1, equation 2. Let's start with equation 1, put it in slope-intercept form. So I'm going to go x plus y is greater than or equal to negative 3. Subtract x from both sides to get it in slope-intercept form, and I'm going to go y is greater than or equal to negative x minus 3. Now I'm in slope-intercept form, and for equation 1, I'm going to go, all right, my slope is equal to negative 1, or I write it as negative 1 over 1. My y-intercept is equal to, I put y, but I really want to say b. Let's do that. Let's say b for y-intercept. Remember, slope-intercept form. My y-intercept is equal to negative 3. Okay, so I have my y-intercept, I have my slope. Now, y is greater than or equal to. Greater than or equal to means solid line, and y is greater than, so I shade up. So there's all the information for equation 1. Now let's do equation 2. Equation 2, first put it in slope-intercept form. And I said equation and I meant inequality. I apologize for that terminology. It is an inequality. Okay, solve for y, subtract 2x from both sides. And I'm going to get 2y is less than or equal to negative 2x minus 2. Divide by 2 on both sides. A lot of solving here. Y. I didn't divide by a negative. I don't flip that sign. So careful. If you do divide by a negative, be very careful. Make sure you flip the sign or this whole thing will be wrong. One little error like not flipping the sign and you could mess this up. All right. We didn't divide by a negative. We don't flip the sign. 2 into negative 2 is negative 1x. 2 into negative 2 is negative 1. So equation 2. My slope is negative 1, or negative 1 over 1. There's my slope. My y-intercept, or b, is negative 1. There's my y-intercept. Y is less than or equal to, so I have dotted. Y is less than, so I shade down. Okay, so I'm just going to circle. Here's all the information to graph equation 1, which I'll do in red. Okay. And in green, here's all the information to graph equation 2, which I'll do in green. So let's do equation 2 since I have the green first. My y-intercept, remember, y is the vertical, x is the horizontal. My y-intercept is negative 1, so I start here at negative 1. I put my dot. My slope is negative 1 over 1. So that means fall first, then run. Instead of rise, over run. If you have a negative, you fall and then you run. Remember, you fall, then you run if you have a negative. Always run to the right, unless you're negative on the bottom, then you run to the left. Okay, so fall first. from my y-intercept, I fall 1, I run 1. Fall, run, fall, run, fall, run, fall, run. If you want to write this as 1 over -1, you could rise, run back. Rise, run back, rise, run back if you wanted. Okay, now this is a dotted, so I'm going to dot this guy. Okay, and then I shade down, so I'm going to shade down. There it is. Okay, now let's do in red my equation 1. My y-intercept was -3, so -1, 2, 3. I kind of colored over it, but there it is. Also, I have the same slope, -1 over 1. So I go down 1 over 1, down 1 over 1, down 1 over 1. I have a solid line because it's greater than or equal to. So my line is going to be solid. But because I have the same slope and different y-intercepts, these guys are parallel. Now, do they have a solution? Yes, because this one I shade up. Look, this one is all up. Their solution is where they cross. So my solution will actually be here in blue. It's the red line all the way to the dotted green line. Where they cross is my solution. And that is how you do number 23. So solve in slope-intercept form, decide the slope and the y-intercept, solid or dotted, up or down. Okay, do that for the second one, put it in slope-intercept form. Careful if you have to flip. Okay, find your y-intercept and your slope. Do dotted or solid, shade up or down. Once you shade them, the point where they cross is your solution. On to the next one. 24, we're almost there, guys. 24, determine whether the ordered pair is a solution to this system. Well, all I have to do when I determine if an ordered pair is a solution, just plug it in and see if it's true, okay? So I'm going to plug in -3, -3 into here. So I could go ahead and solve this system. That doesn't sound like fun. Let's just plug it in. So I'm going to go 5 times -3, sorry, 5 times -3 plus 4 times -3. Is that greater than -4? And then the second inequality, 2 times -3 plus 3 times -3. Is that greater than 2? Well, here, 5 times -3 is -15. 4 times -3 is going to be, I put a plus. A negative times a positive gives you -12. Is that greater than or equal to -4? Well, is it fall? So if this is it, inequality 1, inequality 2. Inequality 1, inequality 2. Does this fall in inequality 1? Well, let's check. -15 minus 12, that's going to be -27. Is -27 greater than -4? No, it looks like it's greater, it's a bigger number, but it's a negative, so it's actually smaller. Remember, on a number line, if -4 is here, -27 is way over here, it's actually smaller, okay? So it doesn't even work for inequality 1, so it's not going to be a solution to the system. It has to work for both of them. It doesn't work for the first one, so I'm just going to go no. I don't even have to check the second one. If you want to, go ahead. 3 times -2 is -6. -3 times -3 is -9. Is that greater than 2? Well, -6 times -6 minus 9 is going to be -15. That's not greater than 2. So it doesn't even work for either inequality. So that's a no and a no. So to see if this is a solution, plug it into both systems. If it works for one, make sure it works for the other. This one doesn't work for either. But to be a solution to this system, it has to work for both inequalities. It has to be true for both. Okay, so let's go on to the last one. For the school fundraiser, students are selling stationery and greeting cards. The goal for each student is to sell at least 10 items. Okay, so 10 either stationery or greeting cards. The school receives $2 for each stationery set that is sold and $3 for each greeting card set that's sold. The goal for each student is to raise at least $30. Write a system of inequalities for the given situation. Graph the inequalities. All right, guys, I'm going to go ahead and have us not graph that on the test. You can graph this here, but it's kind of intense. I'm not going to have you graph it on the test because it's a little much, but let's go ahead and first define a variable. Write a system of equalities and then graph the inequalities. We need to define the variable. So we've got students selling stationery and greeting cards. So let's maybe let S equal number of stationery, or maybe let's do our X's and Y's instead. Okay. Ooh, I do not want that. Let X equal number of stationery sets sold, or amounts for stationery. Okay, and then Y will be the number of greeting cards. Okay, let's set up system of inequalities. The goal for each student is to sell at least 10 items. At least sounds like less than, but what at least means, if I have to sell at least 10 items, I have to sell 10 or more items. So I need to be X plus Y to be bigger than or equal to 10, right? If it's at least 10, 10's the smallest number I'm going to sell, okay? Then you get $2 for each stationery set and $3 for each greeting card sold. So you want to raise at least $30. So I need the $2 times every stationery set plus the $3 times every greeting card. I need that amount to be greater than or equal to 30. At least sounds like less than again, but think about it. If it's at least $30, it has to be $30 or more. So I need this amount to be greater than or equal to 30. So there are my two inequalities. Now if I want to graph these, you can go ahead and solve each for y just like we did here. So if I solve this for y, I'm going to go ahead in equation 1, equation 2, okay. Solve this for y, subtract x from both sides, and it's just going to be y is greater than or equal to, if I subtract x from both sides, it would be negative x plus 10. I'm not going to write it out just for the ease. This one, solve for y, subtract 2x from both sides, and then you'll get 3y is greater than or equal to negative 2x plus 30. Divide by 3 on both sides. And then this equation, so here's equation 1. That was new equation 1. Here's new equation 2. I'm going to get y is greater than or equal to, divide this into both terms. This becomes negative 2/3 x, and this becomes plus 10. All right, look at this. They have the same y-intercept, just different slopes. Okay. If they have the same y-intercept and different slopes, I can scroll up to here and do, let's graph it here. Okay. So I'm going to go all the way up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 10. There's my y-intercept for that first one. And my slope, I know it's hard to see here because it's over the writing, but my slope here is negative 1. Okay, so that means I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Y is greater than or equal to, so it is a solid line. And since y is greater than, I shade up. Okay, so that's an up shade. This one, y is greater than or equal to negative 2/3 x plus 10. Once again, my y-intercept's at 10, but this time my slope is negative 2 over 3. So I go down 1, 2 over 1, 2, 3. Down 1, 2 over 1, 2, 3. I'm going to have to do this in red. And it's going to look, it's including the line, so it's going to be solid again. Something like this. And this one I also shade up. Okay. So my solution is where the graphs cross, this area up here. If I want to do this real quick on Desmos and see what the graph looks like, let's see what that looks like. Okay, I pulled up Desmos and I'm going to erase some of this so I can see Desmos. Okay, and I typed in most of it. So here if I go y is, I wanted y to be greater than or equal to, negative x plus 10, there's your red graph. And then this one I wanted y to be greater than or equal to, not the dotted, I need the equal to part to make it solid. Greater than or equal to. And then if I pan out a little bit, you guys can see, and it's not liking that. I'll keep zooming in, okay? If I zoom in, that's okay. You can see, if I'm all the way up here at 10, these two graphs look very similar. The red part is not the solution. Only the part where they cross is the solution, just like I showed up here, okay? The red and the blue. This little section right here is not the solution. Only this part where they cross, that's your solution. So that's what it would look like. I'm going to have you just graph this on the, or sorry, write your equations on the test. But if you graph, they would look like this. All right, guys, that is it. All right, guys, that's it. Good luck. Let me know if you have any questions.